what is my first step here? What is my first step? How do I test to see if it's a geometric series?
You do A2 over A1.
Right, I do A2 over A1. Can you tell me what A2 is?
Negative 12 over negative 10.
Okay, so it's the first and second terms, and then what do I get as a result?
I got negative 6 times 2 and negative 5 times 2.
Okay.
And then negative 6 over 5.
Okay. Or you could just do 6 over 5. Yeah.
Oh yeah, this is 2 negative 5.
Okay. And then what do I do next? I don't know, what do I do? Okay, A3 over A2 equals?
Negative 14 over negative 12.
Okay.
And then negative 7 times 2 over 6 times 2.
Okay. Okay. So is this a geometric series? No. So it's not a geometric series because these are not exactly the same. So. Okay, so first we compare to see if there is a common multiple, like is it being multiplied the same to get to the next one. So we find out it's 6 over 5. And then we find out the next one to multiply is 7 over 6, which doesn't really help us. Okay, so what do we test for next? Does anyone remember? What do we test for next? So? Okay, how do we test for that? Right, now we're subtracting, so A2 minus A1, which is negative 12 minus negative 10. And what did you get? Negative 2. And then what do you test next? A3 minus A2, which is equal to negative 14 minus negative 12, and we get negative 2. So is this a arithmetic series? Yes, because we're subtracting 2 each time, so it is, therefore, is a arithmetic series. So again, it's an arithmetic series if you add or subtract a common number each time, and then it is a geometric series if you multiply by the same number each time, right? It's either by a large number or a fraction. That's totally fine. Okay, does anyone need more time on number 1? Okay, number 3. Number 3 here. So number 3 says 2, 6, 18, 54, 162. Find the 10th term. All right, can anyone tell me what do we do here? It tells us to find the 10th term. What do we do? And again, this is your homework from yesterday. This is your worksheet number 1. So what can we do here? Does anyone remember? What is our first step here? So it asks us to find the 10th number in the series. Okay, how do we do that? H2 over A1. And I will say that you don't need a test because they say something in the instructions, and what they say in the instruction is given geometric series. But yeah, that's fine. So we could do 6 divided by 2, which is equal to 3. So what's the common ratio here? Right, multiplied by 3. So how would I write the equation? How would I write the equation? So now that I've solved for my common ratio, how do I write the equation now? Anyone remember? Gary?
The first term.
Okay, so the first term, which is, okay,
Times the ratio.
which is,
The power of whatever term you're finding minus 1.
so n minus 1. So if you want to find any term, the formula is a of n is equal to a1, which is the first term, times r, which is the common ratio to the n minus 1 power. You can see here, 2 is the first number in the sequence, r is 3, which we solve for, and then we can solve. Okay, so how do we solve for the 10th term? What do we do here? How do we solve for the 10th term? How do we solve for the 10th term? Right, so we're solving for the 10th term, so n is equal to 10. So since n is equal to 10, we could do a of 10 is equal to 2 times 3 to the 10 minus 1, and we get some ridiculously large number. So we can plug this into our calculator. It would be 2 times 3 to the 10 minus 1 power, and we get 39366. 39366, and that's our answer. So A10 is equal to 39366. Okay, are there any questions on number 3? Okay, does anyone still need number 3 on the board? I'll leave it up for 10 seconds. Okay. Then, flip this or not. Looks like I. So, if you turn the page, I'm going to do the harder one. We have number 6. Which is a2 is equal to negative 12, comma a5 is equal to negative 4. Find the 6th term as of the geometric series. Okay, so then it asks us to find, but then it doesn't give us the whole series. So that's when things start getting a little muddled, right? So in this one, how do we find r? Well, we know that a5 is equal to a of 2 times r. And how many r's are there? Well, there's 5 minus 2 r's that we're going to multiply, right? Because that means to go from a of 2 to a of 5, you times it by 1 r, and it becomes a of 3. You times it by another r, that's a of 4. And then you times it by another r, and that's a of 5. So that's 3 total r's, or 5 minus 2. Right, 5 minus 2. So then we can plug in for a of 5 and a of 2. So we have negative 4 is equal to negative 12 r to the 3rd power. Okay. So what we're solving for right now is the common ratio, so then we could divide by -12 on both sides, and we get 1/3 is equal to r to the third power. And then how do we get rid of this cube exponent? How do we get rid of this cube exponent? Does anyone remember? Anyone remember how to get rid of this cube exponent? Daniel? I would only use the natural log to get rid of an exponent if there's an x in the exponent. But that is a good idea. Could, and you could raise it. But then, So? Right, you can cube root it. So you just take the third root of both sides. And technically you just get r is equal to the cube root of 1/3. If you want it to be even better, you want it to be like an A+ student, you could multiply the top and bottom by the cube root of 3 times 3, because you want to make sure that you don't have an exponent on the bottom, and you get 9/3. The cube root of 9/3. The reason why I multiply by 2 3's on the top and bottom, which is essentially 1, is because I want to get rid of the cube root of 3 on the bottom of my cube root. So what it does is it makes it so that there are 3 3's that are being multiplied on the bottom, and so that's why there's no more cube root on the bottom. But then on top I have 2 3's that are multiplied, which I can just multiply, it becomes the cube root of 9. Okay, so normally, remember on the notes that I would solve for a of 1, and then I would go from a of 1 and solve for a of 6 or a of 7 or whatever, whichever term I'm solving for. But because my r only has one value, I don't necessarily need to solve for a of 1. I can just jump straight to a of 6. If you remember, a of 6 is after which term? A6 is after which term? 6 comes after, right, A5. So I only need to multiply A of 5 by R once, right? Or if you wanted to set it up a little more officially, you could say A of 6 is equal to A5 times R to the 6 minus 5. Then you just plug in, so a of 6, I have no idea what it's equal to. A of 5 is equal to -4. And then r is equal to this monstrosity here. And this is just to the first power. So it's actually pretty easy. You just multiply it out, and then you get 9 to the third power times -4 divided by 3 is equal to a of 6. It's not a very satisfying answer, but that is your answer nonetheless. And that's pretty much it. Okay. So again, for these ones, it's a little easier when you're given an r term that doesn't have two different values. The only time you want to go solve for a of 1 again to start from the beginning is if your r has two values. The only way you get two values for r is if you have an even exponent, and then so let's just say you have r squared, and then you square root both sides, then you would get plus or minus that value. Okay. Then you have to be careful. Okay, I'm going to do one last problem. Does anyone still need this page? Like this problem? No? Okay, cool. I'm going to post this online too, so if you need it, if you're lost, it's totally fine. So number 2 on that same page, you have 12 minus 24 plus 48 minus 96 plus ... This is the, and it tells us to find the sum of this. Okay, the sum, it tells us S5. Okay, so I know how confusing this is. So this is an S, and this is a 5. Does anyone know what does S stand for? What does S stand for? What does our S stand for? So what are we trying to find here? Emily? The sum. So what does S stand for? Sum, right? And then what does 5 stand for here? What does 5 stand for? So you want to elaborate a little bit? So fifth sum. Can you elaborate a little more? Okay, Emily, you want to elaborate?
Maybe like the sum of the first 5 numbers.
Yeah, so it's the sum of the first 5 numbers. I don't know if that's what you're trying to convey, but yes, the sum of the first 5 numbers, right? Because if it's an infinite series, it's going to go on forever, so we have to actually cut it off somewhere, especially if the sum diverges, which you'll find out eventually in calculus if you take it. But okay, so here, what we want to do is we want to first solve for our common ratio, which you can simply do by dividing, which we already know. So we get our common ratio is equal to -2. And then we want to use our formula. So I didn't derive it for you guys, which I think is totally fine. But your formula here is like so. So I'd say the hardest part here is making sure you put it into your calculator correctly. A1 is 12. We have 1 minus -2 to the nth power, which is telling us the fifth sum. And then we want to make sure that it's 1 minus -2. Okay. So to put in your calculator, you just want to be triple sure. So you want to do 12 times 1, and I'm going to do double parentheses here, 1 minus parentheses -2 to the fifth power. Then I'm going to close off this parentheses, divided by parentheses 1 minus parentheses -2 parentheses, and I can actually put one more to close this off. And I get 132. 132. So for this one, I can actually check. I will probably give you a partial sum which is larger, so you can't check. But you can see here that if I wanted to check this series goes, what, 12? It is 12 minus 24 plus 48 minus 96, and then plus the fifth term would be 192. So assuming that I did my partial sum correctly, I should get the same exact answer. And you can see here that if I actually did it by hand, if I just added those sum together, I still get the same answer. I get 132. Okay. And that is my partial sum. All right, any questions on this one? Any questions on this one? Again, I'm going to put this online, so